It's 2 a.m. We're in Sao Paulo. A $10 million production line stops. The issue is just a software tweak. To bring a technician on site, we need to wait 24 hours. But every hour of downtime is costing more than the actual software updates. Back in 2020, when we started building a new IoT solution at BOBST, we had this issue in mind. How can we bring the cloud agility of software development at the shop floor level? Hello, everyone. I'm Jamal Abdelkhalek. I'm a software engineer. I worked at BOBST for nearly 5 years, and now I'm a software consultant. Thank you for joining me today. We're going to talk about edge orchestration at scale. In terms of agenda, I'll quickly go over who's BOBST, introduce you some key features we delivered with this brand new IoT solution called BOBST Connect. And then we're going to focus our subject on edge orchestration at scale. And hopefully we'll get some question. My main purpose is to trigger some discussion around the room. There are some people across various industries, and I think it's interesting to share knowledge. So BOBST's vision, shaping the future of the packaging world. As Florian introduced, BOBST is one of the world's leading supplier of packaging machinery. I like to start like this because it's an impressive number. 59% of all global packaging sales are accounted by industries served by BOBST. We go over 4 sub-industries, which are the corrugated board. Again, I will give you some, like a little example, just so you can picture that in your mind. But corrugated board, folding carton, flexible packaging, and labels. Corrugated board, we have a big boom there. It's mainly around package for delivery. So we have a big boom with the e-commerce. Since 2020, with COVID, it just skyrocketed. Folding carton is an example that you can have in mind to illustrate that is mainly the boxes for pharmaceutical drugs. Flexible packaging will be everything around food, so baby food pouches and similar stuff. In terms of label, it's what you have on your bottle, for example. And you can see the growth of the packaging industry. We're talking trillions here, and going to 2019, $1.38 trillion of dollars. So I said it, the 4 sub-industries. The key numbers here is the installed base, more than 30,000 machines, and some are still running and are older than me. 130 years of experience. So indeed, they started early. And when we're talking about edge orchestration at scale, it's really an important subject. Shaping the future of the packaging world. Everyone here across the room, you're working in a specific industry. For BOBST, it was important to know the end-to-end value chain. So everything starts with the brand owner's idea. You're building a new product. You need to package it in terms of security. Maybe you need also to add some premium to it if you want to sell more. And of course, this arrives until the consumer. So what you guys are going to find in a specific store to buy your product, whether it's perfume or food and so on. And what we try to build, we called it BOBST Connect. BOBST is really a company that is really in the middle of the value chain. We were selling machines, so industrial machines. So it was important for us to be in the middle and provide as much data as we can to our end customer so they can link that to their existing systems. We're talking about ERP system, MES system, MIS system. So I see we had the CMS as a sponsor, so we really rely on them in terms also of hardware and so on. To present you BOBST Connect, we can start with a definition maybe, but there is a saying that data is the new oil. So that was the first pipeline that we needed to start having data in so we can actually give some insight to our customers and link that to their existing system. So the goal was to have one fully connected platform where we could add insight and expertise that we had along the 130 years of experience. So to present you the IoT solution we built, I like to start with a what if, but here I need you to take the glasses of our customer. And if you're in an industry where you're building machines, maybe you can just take the glasses of your customers. I'm pretty sure you can find ideas and use cases that are similar in your industry. So what if you could remotely solve up to 80% of your problems? Being able to connect remotely to a machine, see remotely every layer of software or every different hardware was a big enabler for us. We can solve many issues on customer side without ever stepping on the site. What if you could automatically measure and control the efficiency, accuracy, performance, and profitability of your shop floor? Again, this is something across industry. You can improve only what you can measure, and therefore, for us, being able to provide data, accurate data, to our customer was really important. This is completely linked. So, of course, when you can measure what you're doing, you can know what you can tweak, what you can change in order to use your shop floor to its full potential. We were talking about climate change and energy earlier. So what if you could monitor and save your energy consumption, minimize CO2 emissions for every job? So what we call a job is just saying that we're going to build this specific package. And again, sustainability is an important topic. Being able to monitor that can even help. You know, we have in Europe, especially, so in some countries, there are some incitation across sustainability. If you can provide a report of what your machine consume and what are the CO2 emission, it can help. What if you could minimize downtimes by pre-ordering spare parts before they break and consumables before they run out? Again, I'm not selling dreams. For some people, it's normal. For some people in the industry, it's wow. But that was an important feature that we bring into our customer. What if you could pay per use? This is completely changing the industrial world where you had to buy a big machine and then you're like that for 10 years and you're happy. Here you can even change the paradigm and you can have machines where you pay per use. What if you could pre-configure, monitor, and review your jobs in your front office while focusing your operators on the final optimization only? So here, in the end, for me, it was really funny to go on customers because depending on the size of the company, you have some customers that have very expensive systems in place with lots of automation. And then you have other customers where they are still using paper and every day they print what they're going to build, what job they're going to do. And with our solution, we're helping any customer to do that, either directly by using our solution or directly from their ERP system. What if you could rely on integrated optimization models for guaranteed performance? That's where, again, the importance of data comes in. The fact that we know how you use the machine, we can specifically come in and say, look, maybe you want to produce more, but if you reduce a little bit the speed, the overhead of producing more will save you on cost because maybe going at that speed, your the cost of electricity or something else is higher. So by using those systems, we can, for example, here there is an example. The minimum recommended speed was higher. The dryer's recommended configuration was more economical. The customer was happy in the end because it was not a big change in terms of configuration, but it's data that we can bring along. What if you could automate your quality setup and retrieve a detailed report on each job's execution? Again, we're in a world where everything is going faster and faster, but faster doesn't mean less quality. And at BOBST, we have some specific quality system that can be designed ahead of the job, and you can send that to the machine. So I talked about pharmaceutical industry. You're all maybe aware that you have some braille on the boxes. This is a specific example of kind of checks that we can do at the edge directly in the machine. We can ensure that the break quality is top and that you can validate directly in the machine that a specific package should be removed or not. So basically, what if you had BOBST Connect? I don't know if I convince some of you to buy $1 million machine, but at least some specific use case, some specific features, I'm pretty sure they can be applied across different industries. So I really tried to let this presentation at a high level and not go too technical, but the subject that I wanted to talk about is important and it's a bit technical, is that if you want to be able to ship software in the machine, often you need to talk about edge orchestration. For BOBST Connect, we separated concern into two clear layers. On one side, you have the platform layer, which is really the hardware, the edge device, as we call it. There is an operating system. We talk about it in a few slides. The fact that you have this platform level, you need to be able to remotely update and handle it. And then you have the whole application layer. I told you we started in 2020. At the time, we didn't know which features we're going to focus on, because when we're building software, it's like building a startup. You don't really know where you're going. You need to adapt and have the fastest iteration loop possible. You need to present the product to your customer. You need to have examples. For example, we developed a specific edge module for a customer. We validated the use case, and then it became global, and we are now delivering this edge module to everyone. So tomorrow there is a workshop. You can join me if you want a quick tour of the actual BOBST Connect application or anything that's around. Today I'd like to talk to you about edge orchestration. So I started with that sentence. For us, one central challenge from day one was, how are we going to manage thousands of edge devices across continents without ever stepping on site? The answer was building the edge device around several layers that could be remotely updated and handled. I will go through every layer after, but really keep that in mind. I told you that we had an install base of 30,000 machines, and it's growing every year. Of course, the old machine, we need to do a specific retrofit, but for all brand new machines that are sold, they are all connected. So the original pain points around the edge was that remote software updates were either done by a service technician on site. If some of you are in the industry, maybe it's business as usual, and you're like, oh, I don't know why it's weird. You should ask yourself some questions. Remotely, but done device by device with manual intervention. This is also a common way to do software update in the machines. We have device and OS diversity in the different existing machines. Of course, the brand new machines, we try to have a common path, but in the end, BOBST is a group, and the sub-machine are a bit different. We didn't have a centralized way to manage security, network, version, or rollback across a global fleet. And that's a super important base that you need if you want to develop software and be able to ship new version every 2 weeks. So basically, I come back to this. We needed the agility of cloud development to the shop floor. So to solve that, we were looking for a specific solution. We needed a solution that would be hardware agnostic, secure by design, could scale from proof of concept to global deployment without hard constraints, could enable us to remotely provision, manage, and update edge devices from the OS to the main runtime, and could integrate perfectly with our existing cloud infrastructure. That was everything we needed. How we solved that, to be able to explain, I will quickly explain you what is ZEDEDA, because we choose to partner with ZEDEDA, again, to choose where do we put our focus. The focus of BOBST, I told you earlier, is really around data, around bringing insight on how to use the machine, how to improve productivity. It's not to handle edge device at scale, to do remote update. ZEDEDA, they have a specific stack. I told you earlier that we had a cloud IoT solution, so it was important to be integrated with that. To explain what is ZEDEDA, I always like to start with Eve, which is the operating system that we use. So Eve, it's an open source operating system that is Linux-based. ZEDEDA is the main maintainer of Linux. Today with us we have Eric Northmark, which is the CTO of ZEDEDA. Hopefully tomorrow we can have more insight about that. Eve is completely and remotely managed by the ZEDEDA backend that is cloud-based. And basically, you should see ZEDEDA as the cloud-based steward of EveOS, where you can remotely manage, update any layer on top. So again, maybe this is a bit technical, but we'll try to go not too much into details, but EveOS gave us a trusted base layer with TPM integration and remote certificate generation, securing our edge hardware. So I will not go too much into security, but maybe just give a few words about TPM and remote certificate generation. We have a global fleet, which is global, as I said, but also in China. So TPM, you all have that specific cryptographic chip in your computers, but in China they have their own system because everything is easier in China, or not. So for China, we're using specific certificate generation to still have a secure hardware, but what you need to do is you need to know that a specific device is sending data, and you need to be able to know if it's yours, yes or no. I can say that today we deploy and update full EveOS and our Ubuntu virtual machine remotely with confidence and control. Again, I will go through each layer just after. The big value for us is that all ZEDEDA's functionalities are fully embedded in BOBST Connect, our application, so our ops team doesn't need to go in another platform to use that. And we completely delegated the lifecycle management of our devices to ZEDEDA. For the application layer, we're leveraging Azure IoT Edge Stack. So maybe a diagram, it's going to be easier to talk about this. So as I said, we have our hardware. For the moment, it's Siemens. It depends on the specific use case, but for the IoT Edge solution, we use a specific IPC 127E, not really important, but Eve can go on any hardware, or any hardware that we use at least. We leverage Eve to have hardware metrics, to do fleet management and remote update. The main runtime that we have is Ubuntu. It's a virtual machine. I showed you a slide earlier. With ZEDEDA, you can have virtual machine, Docker containers, or even have Kubernetes at the edge. We chose to have Ubuntu because it was the main runtime recommended by Microsoft. Those two layers, we update them as less as we can. We're just using the LTS version, let's say, because, again, that's not where we have our businesses. That's not where we have value. Our value is really here in what we call the IoT Edge runtime, which is a collection of software provided by Microsoft. In the end, we have specific edge modules which hold our business logic, communicating with different devices that are in any machine. Getting data, I saw that OPCUA Foundation was a sponsor. So for example, communicating with an OPCUA server, getting data can go from 10 variable to maybe 1,000 variable every second or every 10 seconds, depending on the configuration. And yeah, we mainly leverage what we call IoT messages. They hold telemetry data, which could be sensor data. So it could go from temperature, machine speed, total output unit produced, and so on. This layer, we update it every 2 weeks. Every 2 weeks, depending on customer feedback, depending on features development, we can update it, and we don't think twice. We have a cadence of development. We have a specific goal. We're following Agile Scrum methodology. At the end of the 2 weeks, we just ship software, and it goes globally like that. Nothing to manage. For those 2 layers, let's say that I am on Ubuntu 22, I go to Ubuntu 24. I just update what we call the edge app on ZEDEDA side. And again, either I can choose to update my whole fleet, but we are not that crazy, so we choose a specific subset of devices, and we do the update remotely. Again, this is a bit technical. For anyone that is interested to talk about this more in detail, I'll invite you to join us tomorrow during the workshop. We can give you more insight about that and do a demo about that. So some lessons learned is that cloud practice can be adapted but not copied. So in the end, I just showed you that we were able to ship software every 2 weeks. Okay, cool. But every piece of software that you build that is at the edge, you should not forget that you have specific constraints, real-time constraints. The machine should be running. You cannot just stop the machine, right? The fact that you can have a very bad network. Feedback loop is a superpower. So again, I'm not inventing anything here, but the fact that we could ship software every 2 weeks, even at the edge, was a game changer for us, because we were developing a brand new solution, and you're trying something, you're presenting that to a customer, maybe to 10 customers, and if something goes wrong, you can roll back. It's the best way to build a product that is an actual product market fit. Edge is part of the product. This is just a few words, because sometimes there is a big challenge to have IT and OT converge together. It's one of the main subjects in the industrial world. But really, Edge should be thought of as part of the product, whether it's hardware or software that is running on top. Edge computing and device management is a must. So we are in the era of AI. With the structure we have, if right now I wanted to have an AI model that goes at the shop floor level, that analyzes the data coming in from any machine of our customer, I could do it in 5 minutes. So if I was a bit crazy and we didn't have any, let's say, methodology of development, I could literally do that in 5 minutes and deploy that at scale. Device management is a must. Again, I will come back to it just in the next point. His partner can help you go faster. For BOBST, device management was not a business need. We needed to delegate that. We partner with ZEDEDA for this. Same for the Azure IoT stack. We did not want to reinvent the wheel, and we leverage Microsoft Azure IoT stack. So a summary of everything I said. The solution we designed is an end-to-end digital solution driving packaging productivity. It's integrated with ZEDEDA for device lifecycle management, and it relies on Azure IoT Edge to handle all the device business-oriented modules. So I hope that now you all think that you can make your machine fleet ready for agile methodology and develop software and deliver it as soon as you can. Any question? Go ahead.
I'm wondering, you talked a lot about measuring and data acquisition. Do you do the same thing for control for the PLC that you have inside the machines? Is that running on the same level?
So very good question. So in the end, for this new IoT solution, we were a bit the prototype across the whole machine. So for the moment, we're mainly having a gateway, so we are communicating with those PLCs and so on, but we don't actually remotely update those PLC like that yet.
So this means on the top of your IoT Edge device, there's only the measuring software running, not the PLC application, correct?
Correct, yeah. So the hardware is separated. There is still the existing hardware for the PLC and automation, and we are just building the IoT Edge modules I showed that is communicating with those PLCs or those specific devices that are in the machine.
Do you dare to bring that both together on one hardware in the future?
We'll try. Yeah, so that's the goal in the end. And if you see all the new trends, or I told you that we're using Microsoft Azure IoT Stack, let's say the new era of Industrial 4.0 for Microsoft is having everything virtualized, and actually they're even maybe crazier, but having only one server in the whole shop floor with virtualized stack that you can run all the machine from there. We are not there yet, but this success story for us building this new IoT solution, having a bidirectional way to communicate with the machine is already a big step. I didn't say it, but we need to keep up. I think in some industries we're a bit late, but if you take the automotive industry, we're following the same path. At the beginning it was only mechanical, then we added electronic, and now we're adding software. If you have a Tesla, you move it with your phone. We're not in the packaging industry, we're not yet there, but we're going there, yeah.
Just to add one comment, we're having a case study on that tomorrow morning. First, the keynote tomorrow is about virtual control. So, Jamal, thank you so much.
Thank you, everyone.